Hey folks, Nathan here. Your rocket's launched, it's gone up, it's come back down, and now you want to know on the spot what the apogee was. You didn't bring your computer with you, so you can't just pull out the SD card, and you're only using an Arduino Nano, so you can't spare the pins for an LCD or 7-segment display. You're low on funds, and you don't want to pay tens or even hundreds of dollars for a commercial altimeter to strap to your rocket. You need a cheap and elegant solution, and that's what we're looking at today. We're going to be reading out a 3-digit integer using only a single LED without having to worry about long wait times or losing count. Let's get into it. Your first thought when you heard single LED was most likely one flash per unit. So if the rocket went up 30 meters, the LED would flash 30 times. But that's not what we're doing here. That'd take way too long to worry about, and you'd lose count by the time it got to 15. So our goal here instead is to split the apogee value into its individual units. So the hundreds, the tens, and the ones units are all represented separately, and then we show them individually. This way, even with a 999 meter apogee, at most we need to worry about 3 groups of 9 flashes. So let's jump into the code for that and show how it works. Here is the code for altitude detection using a single LED. So first off, we define our LED, which is readout pin in the code, which is going to be on pin 7. We do our serial and we set it up. We're using serial here because it's just plugged into the computer, so we can just type in whatever altitude that we want and it'll display it. And that's essentially all that this part here is doing. We have our, if there's serial data, get the value. If the value is real, print it out. Otherwise, do some error checking and just say non-integer entered. This isn't essential by any means, but this is more just the programmer and me not letting it not have error checking. So now we come to the meat of it, which is our altitude readout script. So we start out with a 1.5 second flash here. This is just so that when data starts being read out, we get this advance warning so that we don't risk losing the first part of our data. Then we get our units separately, so our hundreds, our tens, and our ones we get as their individual units. Then we do our one quick flash to say that it's the hundreds unit. We then do 1 flash per 100, 2 flashes for the tens units, and then 1 flash per tens value. And then same again, 3 flashes for the ones unit, 1 flash per ones value, and then a quick bunch of flashes at the end just to show that we're done. So it may seem a bit confusing as to why we have these sort of 1 quick flash per 100, 2 quick flashes for tens, and 3 quick flashes for ones. The reason for that is that it's important that we know what unit is being read out, because we've only got the one LED, and if we skip a unit, we need to know that that unit's been read out right. So if, for example, we were to do 101, we'd have 1 flash for the hundreds value, 0 flashes for the tens value, and then 1 flash for the ones value. So without some sort of warning as to what unit we're currently reading, we could confuse this for 11. So we just get the 1 and then the 1, or alternatively we read it as 110 meters instead of 1, because we see 1 flash, and then possibly 0 flashes. Okay, and with that explanation, let's see it in action. Here is our Arduino with our light. You'll notice this is the same circuit as the BMP280 test from the last video, but we're just using the LED for this one. So we have our LED connected via USB, and we have our serial monitor up here. So let's open that up. Alright, clear our output. So let's just first off put in some random characters just to show that our error checking is in. Excellent. Alright, so let's start off with an easy one. Let's go for 5. We can see hundreds unit, which is 0, tens unit, 0, ones unit, 1, 2, 3, 4, 5, and complete. Wonderful. Let's go for 16. Hundreds unit, nothing. Tens unit, 1. Ones unit, 1, 2, 3, 4, 5, 6, and there we go. Complete. Let's go for something bigger. Let's say we hit 286 meters. Hundreds. 1, 2. Tens. 1, 2, 3, 4, 5, 6, 7, 8. Units. 1, 2, 3, 4, 5, 6. And then we have 286. So if we want to go all out and go for 999, we can see how long that's going to take. So hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9. Tens. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. And complete. So there we go. Obviously it's not as quick as a digital readout would be or anything like that, but it does let us actually check our altitude that we reached just on site without having to worry about bringing a computer to plug an SD card into or having to add a whole heap of extra wires just to handle a digital screen. So with this as well, if we do go above 999 meters, which this rocket won't, I'll just say that, but hypothetically if we did, this is still going to work because our units are just a number of hundreds. So if we go back to our monitor and we put in, say, 1208, we're going to get our hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our tens, none. Our units, 1, 2, 3, 4, 5, 6, 7, 8. So we had 12 hundreds, 0 tens, and 8 ones, and that gives us 1208. And that's all for today. We were able to create a system that allows a single LED to comfortably read out altitude values up to 1,000 meters. This may not be as useful for feet, as you reach higher numbers much faster, but you could possibly adapt the code to give a thousands unit as well to accommodate for this. If you're reaching the point where you need to read out tens of thousands of units, your rocket's likely advanced enough to have a better system than this one on board. If you're just starting out with flight computers, or if you're a hobbyist who's trying to spend as little money as possible, then I definitely recommend this kind of setup because you can very easily get altitude readouts for the cost of a single LED. And that's it for this video. Catch you later.